first news report from Behind the Math News, aka BTM. We, Behind the Maths, believe that the application of mathematics is a crucial element in our daily lives, and it should be recognized for its true glory. Tonight, we shall be focusing on the topic exponential growth and decay and how it is needed more than ever in our society. We have separated the three subjects into simple interest, compound interest, and half-life. But first, we have a report about simple interest. Now over to Judy.
Simple interest is a quick method of calculating the interest charged on a loan. When somebody lends money to somebody else, the borrower usually accounts a fee to the lender. This fee is called simple interest or flat rate interest. The amount of a simple interest is a fixed percentage of the amount borrowed that is paid each year.
We can write this in a formula. P times R times T. P, which is principal, is the amount borrowed. R is the rate of interest per year, and T is the time in years. Daniel leaves $350 in his bank account for 3 years. The account paid is interest at a rate of 8% per annum. How much does he have in his account after 3 years? The interest for 1 year is 8% of $350, which is $28. Then to get the interest for 3 years, we do 3 times 28, which is $84. To get the overall new balance, we do $350 plus $84 to get $434. This is the amount after 3 years Daniel will have in his account.
Next, over to Lisa, who will explain compound interest.
Compound interest is interest paid on initial principal calculated by the money you have borrowed or invested. You earn interest on the money you deposit and on the interest you have already earned, so you earn interest on interest.
In finance, savings accounts that carry a compounding interest rate are common examples of exponential growth. The power of compounding is one of the most powerful forces in finance, as it allows investors to create large sums with little initial capital. Here, the interest is added to the principal at the end of each year, so the next year the interest is worked out on a larger amount of money than what was originally borrowed. For instance, $2,000 will grow over 2 years for investment at 5% per annum, compounding yearly. To solve this, therefore, the simple and compound interest is necessary for the future, as it allows individuals to increase their income and accurately calculate it.
Thank you for such great insight. Up next, we have Christine and her report on half-life.
When an atom of a radioactive isotope, which is a variant of a chemical element on the periodic table, decays, it releases radiation and forms a different, usually lighter nucleus. The rate at which these isotopes decay is described by its half-life, the time you would need for half of the amount of the radioactive material to decay. For example, carbon-14 has a half-life of 5,700 years. If you had a 1 kilogram lump of carbon-14, after 5,700 years had elapsed, only 500 grams would still be carbon-14. The other 500 grams would have decayed to form the stable isotope nitrogen-14. Of the substances used in cancer treatments have half-lives of only a few hours, while uranium-238 has a half-life of 4.5 billion years. This calculation of radioactive decay is vital in ensuring the elements do not prove harmful to society, like the incident that occurred at Chernobyl in 1986.
The formula In n to t over n to 0 equals negative kt, nt equals mass of radioactive material at time interval, n0 equals mass of the original amount of radioactive material, k equals decay constant, and t equals time interval, can approximate the decay of various isotopes.
Thus, the half-life of an isotope is imperative as it enables the dating of artifacts through elements like carbon-14, allows for the calculation of how long radioactive waste must be stored, and enables doctors to use safe radioactive traces.
And all living things out there, plants, everything, they are always constantly, during their life, taking in forms of, so they're taking in carbon-14, okay? Small amounts of carbon-14. When you die, you stop taking in carbon-14.
Of BTM News. Thank you for watching this broadcast. Up next at 6 p.m. will be the state reports, so make sure you stay tuned. The state of Pythagoras, I'm looking at you. See you then.